All right, now that we've defined the idea of a scalar line integral of a function over a curve, let's go ahead and look at some examples. So question 1 on the worksheet says compute each line integral. In part A, we're looking at the integral of the function x over x squared plus y squared over the curve C, which is the quarter circle centered at the origin of radius 2 in the first quadrant. Okay, so here is our curve C, and the first thing we're going to need is a parameterization of this path. So I'll go ahead and use the parameterization. R of t is 2 cosine t to sine t. And since I'm just looking at this quarter circle here in the first quadrant, t will vary from 0 to pi over 2. So this gives us a counterclockwise parameterization of this quarter circle at t equals 0. We're here at the point 2, 0. And when t is pi over 2, we're up here at the top at the point 0, 2. Okay, so when we go to set up our line integral, our bounds for the integral will be from 0 to pi over 2. And now for the integrand, we're going to go ahead and just substitute in these expressions for x and y that define our path. Okay, so I'll get 2 cosine t up in the numerator, and I'm going to divide that by 2 cosine t quantity squared, that's x squared, plus 2 sine t quantity squared, that would be y squared. All right, the other thing we need is this differential ds, which recall is a little differential arc length along our path. And we argued in the intro video that this is equal to the magnitude of the derivative of our vector function r that defines our path. So in other words, it's the speed of a particle moving along this path according to this parameterization times our little change in time. So speed times time is give us this little differential change in distance. Okay, so now I want to compute the magnitude of the vector minus 2 sine t to cosine t. Right? I just differentiate component-wise with respect to t. And now the magnitude of this vector is the square root of minus 2 sine t quantity squared plus 2 cosine t quantity squared. And then I have my dt. And this simplifies a lot, right? This is just 4 sine squared plus 4 cos squared. So that's going to just give us the square root of 4, which is going to all then simplify down to just 2 dt. Pretty nice. All right. So this is all going to boil down to a pretty simple integral in the end. This denominator, just like we saw here, this is 4 cos squared plus 4 sine squared. That is just simply 4. And so now notice I have a 2 times 2 is 4 divided by 4. So those are all going to just divide out, and all I'm left with is just the integral from 0 to pi over 2 of the cosine of t. And so I'm going to get sine of t evaluated from 0 to pi over 2. And that's going to give us 1. All right. In the next video, we'll look at part B. Thanks.